Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about energy-based warfare. So let's dive deep into it. So you have to understand, war was always energy intensive, always. Now we started with elastic energy, basically bow and arrow, this puppy. That's how we started. And then we started to utilize clever designs where we used gravity as our spring. So this was the elastic era where we were just like eating things based on muscle power or fume power. So that's how we started. Then we entered into the chemical era. So this is the chemical era. The chemical era is whether we have explosives or propellant. Basically, propellants does the Amazon 24-hour delivery and explosives does the actual delivery. So that's how we started. And your Pum Pum is also explosively powered. So everything works so far. Now you be like, hey, don't we have something even more powerful like E equal to mc square? Yes. Factually, absolutely, realistically, yes, undeniably, we have God level power, as in there is no chemical equation, there is no theoretical framework of energy where we can get more energy out of that. Like flat out, E equal to mc square is the upper limit. How efficiently you get that, that's up to you. You can have fission, you can have fusion, you can have antimatter, but we got it. Like in terms of what we can do, we got it. However, it's too much. That's the problem. Even with basic bitch fusion system, it's too much. So that creates the issue. It's like, what the hell you gonna do? It's like if you boom something and that's completely gone. That's not acceptable answer. So, and not much radiation and all that jazz. So we need a new era. Now this new era started in early 2020. So this era is fought with energy. Now this time, what is the energy source? We had elastics, we had chemicals. So what is here? Here we have fuel. Now fuel is more powerful than boom powder. Like what? Well, yes, of course, like a petrol has more power than RDX. Then how that can be? RDX has the benefit of dumping all the energy very quickly, and it is self-sufficient, meaning it has two components inside of it. It's almost like a monopropellant rocket engine. Petrol has more than enough power. That's why we use those sort of things, petrol, fuel, into rocket engines to actually go to orbit. And that's why liquid fueled engines are far more powerful than solid booster. Solid booster gives you the oomph, the G forces and all that. But liquid fuel is like, bro, I got the speed. So fuel powered and semiconductor based. Basically, any country that does not have good semiconductor, they did. They did. So this is the era that we are entering in 2020. So let's start with the oldest design that everybody started was Railgun. Now Railgun is a realization of the fact that physics says if you have a barrel length that is logical, that you can actually build and manned and do whatever you have to do with it, will have a diameter. Basically it will have a diameter and a length. So that ratio, diameter to length ratio, would be a reasonable amount, let's say 1 to 50. So when you have that diameter to length, there is a limit how much speed you can get out of it, how much velocity your projectile can get out of it. Does not matter what you use. There is a law of physics that says like you can only get this sort of velocity, you cannot increase it. Like we have reached that saturation, like a World War II gunships, those puppies, that destroyer that gives out love, yeah, that's the highest you're gonna go. Like, and again, you can push it a little bit further, but you will reach a point where you are destroying the barrel rather than actually sending something. So there is a physics-based limitation. There is like a law of physics that says like, yeah, you really can't do much practically. You can increase the barrel length, which was tried with some boom guns that sent things into space, but you have to understand it's not that effective, and it's not orbital velocity, it's only orbital height. And what do you need if you need orbital velocity? At that point in time, you are looking at a boom accelerator, basically a boom, 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 boom. You have to keep doing, only then you can do that. So that's not practical. So there is a law of physics that says like our pew pew is reaching a final form, whereas like we really can't expect much more out of it. However, Railgun enters the chat, and Railgun says velocity, yes. So the velocity of a railgun is directly limited by your energy supply, meaning if you are like in Expanse where everybody has fusion reactor and they have giant as railguns, they can go YOLO on it. They can like literally fire at like few percent of speed of light. So speed is not limited, velocity is not limited, it's directly limited by your power supply. And it's actually efficient. So how much megajoule energy you have in your capacitor bank and how much gets dumped into the projectile, it's surprisingly efficient. Like it touches double digit, meaning more than 10% efficient, real world one. So that's good. That means you do not have to run like, like same way we have back in the old days of laser ignition facility, that was barely 1 to 2% efficient. Now we have lasers that are like 20 to 30 and some military that reaches 50%. Same thing here. So it's efficient, it's fast. Are there any downside? Yes, there is one downside. Downside is that it's not self-starting. Meaning, if you ever watched any video, even the Japanese one that they are launching right now, it's like, why the heck there is this going on? Like, what is this? Like, why? Why do you have, whenever you are firing something like this, it's like, why there is this big flash? Why the heck that is there? Well, it's not self-starting. So you have to give it a nudge, because if you do not do that, you have two conductors and something is touching this. The moment you dump the energy, it welds. It just welds. It does not dump your energy practically. It's just like, okay, it melts, and it welds, it melts. So how do you make sure the magnetic field gives you the energy? You need to give it a nudge. And the amount of energy, the amount of magnetic field, you need a way of non-contactively dumping the energy. So basically, gas charges be used. On small scale, you can try putting magnet bottom, then that will give you the acceleration, but good luck. So that is why they use hydrogen to push it. Like in some scenario, they have hydrogen. I'm pretty sure they must have changed it. But that's the plasma that you are seeing it. And yes, there is a rumor that if you really dump bonkers amount of energy, you can throw plasma bolts out of it. Meaning no physical projectile, just plasma as a bolt that can destroy things on the other end. Now, not very far. Plasma dissolves very quickly, but it can be done. Meaning actual that can be done. In principle, in physics, it can be done, but I don't think it can be done in like with current constraint of technology. So it has no self-start, and it's self-destructive. This is the biggest hassle with this. Meaning, yes, putting a bit of charge, yes, it compromises your stealth. It does because again, you may be like, hey, in daytime it won't be that obvious. Yeah, it won't be obvious in optical spectrum. It will be. You can see this puppy from satellite. In infrared spectrum, this puppy is that bright. So you lose stealth, but okay, that's acceptable. That's like even our old systems were not that stealth, so we can live with it. But the fact that it self-destructs, that's the biggest hassle with this, because it's physically making a moving contact while transferring bogus amount of current. You are talking currents that are in kilo amps or sometimes in mega amps, and you are like, that is brutal. So that conductor, like first that pipe is like doing like this, like magnetically it's doing this, so it's very destructive. Like the barrels, now be mindful, every realistic real world barrel has limitation. They will be like, hey, you can only shot it, let's say if it's ludicrously high power, 100 times. Some system is like 5,000 times, but it's not like, you know, you built it and you forget about it. There is a limitation. However, these things are like good luck if you get even, you know, few hundred shots out of it. Again, it can be overcome if you have a swappable barrel design, or you just brute force enforce it like there is no tomorrow. But these two are very serious limitation. No self-starting, meaning any failure in the system, it will just poof the whole system. And self-destructing practice like makes it more expensive. Lot of R&D was put into it, lot of time and lot of money. However, as of now, when I'm making this video in 2023, it's not in deployment. And heck, the whole there was a new series of destroyers built just to house these things. They were cancelled because it was like, realistically, the yield rate is just not there. Like the barrels are like, we good, we fire it, and then second shot is like, yeah, the coupling efficiency is again eroded. Every time you're firing, it's eroding it, so it's brutal. So will we see this in future? Of course, some amount, but I do not expect this to become the major boom scenes. It does have efficiency, but other than the fact that it does not self-start and the fact that it self-destructs, it's a bit difficult pill to swallow for army generals. Then we come to its more less known cousin, but more wiser cousin, that is Coilgun. Now, Coilgun is basically electromagnetic coil that you are turning on and off very quickly. Now, benefit, self-starting, meaning you do not have to worry about it. And it has no speed limit, same as a railgun. And it's smooth, meaning railgun gives very violent jerk, ludicrously violent junk. Meaning if you want to put optical sensors in your projectile, yeah, good luck with that. It's way too brutal, like thousands of G. Like the numbers is bonkersly high. So it's very difficult when you're talking about railguns. Here you can make it smooth, especially if you have a long barrel, like let's say a battleship kind of barrel, you can make it gentle AF. Like comparatively speaking, compared to railgun, this can give you much smoother acceleration. And that has multiple benefits, because be mindful, action equals reaction. While you do not have a boom going on there, you still have action equals reaction. If you make it smoother, that means all the shock absorber will last longer. That means the fatiguing on your metal structure would be less severe. So shut up, take money. Are there any side effect? Yes. It's inefficient, meaning if that puppy gives you, let's say real world 10%, this puppy, if you are lucky, will give you 5%. Now, again, some modern designs, some energy recovery systems claim 22%, or sometimes it should be possible, but do not expect very high energy efficiency, meaning your capacitor bank would be much bigger to match the same power as a railgun, or if it's the same size, it will give less velocity. And the biggest reason why it's not deployed everywhere, even though this could have been built like long ago and it has been built, it's just that it requires very high and very fast switching. Now, fast switching is the problematic problem, because high switching, we had vacuum tubes that can switch like ludicrously large amount of current. That's not that big of a deal. Fast is the problem, meaning first coil starts very gentle, like these are the coils. So first coil is like, hey, I'm just breaking the inertia, just like getting things going. It's super easy. Second coil, okay, it's a bit faster because again, you piled it up. The last one, it would be like, you take that coil, you stretch that up in time, and you have to be like, okay, the projectile is starting to enter. Okay, charge the coil. Coil is charging, fully attracting. It's reaching the center point. It's not reached yet. It is reaching it, and you have to collapse the magnetic field so it does not jerks it backwards. All of that has to be done so precisely, so quickly, only then you can get the efficiency. Majority of the time when YouTubers build it, or even tech tubers builds it, they do not get the efficiency. Even though on paper the capacitors are so powerful, even if you are calculate the mathematics, and it's like even with few percent efficiency, that should be like, you know, very high. Yeah, that's the issue. The switching efficiency is not there. It requires ludicrously high switching. And to give you a context, in 2008, when US Army was building a electromagnetic motor system, they had this system. 94 gigahertz radar was used at the base to do the firing sequence, meaning that's the difficult part. So if you can do that firing sequence, and be mindful, in later coils, it becomes brutally difficult to like dump all the energy. So it becomes like it adds energy and then shuts it off quickly enough so you do not have like, you know, pulling it back. Or and be mindful, pulling it back does not mean like it will actually be pulled back. It just means the total velocity will be decreased. So it requires brutal amount of engineering. Coils are not that difficult. And what kind of magnetic oomph we are talking about? Yeah, that motor system, they achieved one of those coils, 25 Tesla. You were like, wait a minute. That is bonkersly high. Like we have MRI machines that barely go from 1.5 Tesla to 3 Tesla. Some touches 5 Tesla. How the heck that tiny thing at 25? Well, it's pulse. That's why it can survive that without superconductors. Even like you can buy it. Like if you have money, you can buy it from people who have built coil guns, which coil can easily reach around 5 to 8 Tesla. It's doable. It's the pulse part. That's the highest issue. It's not the technology part. It's just switching it reliably. Optical systems are not efficient. Like you are talking about in picoseconds. You have to turn on something, dump all the energy, turn it off. And some scenarios, they have energy recovery. So the back EMF is captured rather than wasted. So all of those things makes it difficult. So ironically, the structure part is the easy part. The hard part is the switching. Now, a lot of R&D has been poured into it because this was 2008 research and paper, and I do not recall where I saw it. Did I saw it in Future Weapons in Discovery Channel, or I saw in some YouTube video? I did saw a demonstration of this, and it's scary. Now, why scary? Because it's completely silent. Yeah, that's another benefit of it. It's silent. There is no charging gas. There is no boom. It's like. So it does have a lot of R&D, it's ready to use and may be already in use. Like for example, China just claimed they have already fired this puppy, which is an artillery shell. Can it be done? If you have the energy, you have the switching power. Energy is the easy part. Switching, if you have the switching that is fast enough, it can be done today. So what is the benefit of having this system? Well, quiet heating, meaning would it make sound? Absolutely. It will make the sound of the projectile leaving the barrel and the shock absorbers. So it will make sound, that's there. However, it won't be like in the motor design, again, it was creepy. Like they just fired it here. They had a catcher mechanism there. They fired it. Nobody was like, something happened. Oh, yeah. They opened the catcher and it's like, yeah, there's the magnetic armature. It was like, what the hell? It's quiet. And if somebody put rocket assist, the idea was that they're going to have a motor and they're going to yeet it. So what they were aiming for is like higher range than normal conventional, propellant charge. So imagine that. But instead of making it that powerful, they're like, hey, just make it low power, low cost. Everything is like, wouldn't that decrease the range? Oh, absolutely, it would decrease that. Instead of motor shells, put rocket propellant cells there, basically RPGs. Now heat the RPG shells, forget about the range, forget about the sound. Your employees are like, we good, sir, no hearing damage, we good. Enemies don't know our location, and this very lovely, very long range system is gonna make some extra love far away. It can be done today. So any country that is wise enough and investing a lot of money into this, especially if they're solving the sequencing problem, they're gonna have a weapon system that you do not want to, because you won't even see it. It won't be like Expanse where it's like pachung, pachung. It won't be like that. It's like gone, sir. You're gone, sir. So Coilgun, it's very powerful. Like this part scares me. Railgun does not scares me that much. This scares me. Then we come to the laser. Now, laser fever was very old, as old as Star Wars, and Reagan went a bit high with this. I'm not joking. This is not made up. This is real. He wanted actual nuclear warhead going boom, creating enough X-rays and gamma rays to create laser in X-ray or gamma rays and point it to multiple incoming warheads, so it can boom all of them simultaneously. A bit high. The dude went a bit high. So from that imaginary idea to real wars, we have reached it. As in, after 2022, many wars already have laser deployed. Now, of course, power ratings vary, but it has been deployed. So how the heck that happened? Well, development of fiber laser changed everything. Before fiber laser, somebody was thinking about pumping a laser using a boom device, or pumping a laser using chemical, like that Air Force flying laser, that was a chemical laser. And fiber laser is the first time where we can actually go bonkers amount of energy efficiency using fiber laser, meaning your electrical energy to actual laser output is very high. Meaning if you are poor, you can buy 5% to 10% right now. If you are rich, you can buy a German-based laser system that can be 20 to 30% efficient. If you are military grade, which again, I have no verification, but it should be possible, 50%. So that allowed war system to be used, and power can be scaled up, because here's the deal. Right now, if you have money, you can just go to a company and buy a 70 kilowatt cutting laser. Like, you can just go there, pay money, get it. Now imagine what is the output. Output is a freaking fiber. What if you bundled up multiple of fiber of those? Now 100 kilowatt is like, oh, it's a 2 unit. 300 kilowatt is just 4-5 unit. As long as you can provide the electrical power and the space needed and cooling, you good. It scales up very well. Now, 50% efficiency means like portable units can actually be powerful. Otherwise, it has to be powered by some big gigachat generators. And the biggest benefit of this is light speed. It's not gonna go there, it is there. If you're seeing it, is there, meaning no matter hypersonic speed or hula speed or orbital velocity or whatever have you, if you can see it, the end, like it's done, Are like, what about aiming, steering the beam? Yeah, you are just moving the mirrors or a small motors, which can be done very effectively. Have you ever wondered how the heck we track the shots of artillery shells or that railgun shell? It's just that camera is static, they are just moving the mirror. Mirror can be much lighter and it can be moved much faster. So same logic with fiber laser system. So laser banks is like, that's static, it's just the fiber that's like, so it can be done quite efficiently. So you cannot be like, oh, what if I dodge the laser? Yeah, no, sir. No, you're not gonna dodge it. So light speed, super long range, everything is awesome. It does have issue of like bad weather and all that, but again, increase the power to brute force your way through it. The moment we start to touch 10 megawatt, it will be more than enough to stop some serious threat. 100 megawatt, yeah, ICBMs would be like, bro, be mindful, hypersonics would be stopped much earlier than that. It's like, why? Well, hypersonics are already at threshold, meaning when it's fighting through the atmosphere rather than going in the vacuum, its heat shield is already stressed. That, of course, you will design that, and you will not put a super duper hyper heat shield. Why? Again, where would be your payload? So for that reason, it has to be like a very compromised state, and if you just dump a few megawatts of energy into it or pulsed system, you can overwhelm it. Now again, it's not necessary that you're gonna go poof it. You can cause it a deviation out of that, and at that speed, minor deviation is like, yeah, it's gonna miss by like at least hundreds of kilometers, or not hundreds. Like if it's a very close, you are seeing through the horizon, you're looking at like you can make it miss by 1 kilometer just with low power laser if you can aim it properly, which can be done. So this is the current gen orgasm that everybody is having. Like railguns tried, did not work. Coilgun, really good. It does have some serious potential, and especially in mortar, that scares me. But laser is like, bro, don't worry about the problems. And this is Israel's puppy, that is 100 kilowatt. USA claims that they have 300 kilowatt unit, which given the fact of USA, I do understand that most likely they have. But let's see. So this is the laser side of things. So now let's talk about the power side, because yeah, without power, all these weapon systems are pointless. It does not matter whether you have railgun or coilgun or lasers. If you do not have power, they are pointless. So how the heck you gonna provide the power? Because be mindful, back in the days, old days of systems, the logic was like for your car. Same logic was applied in cruise ships, warships, and all that. It's like they had a main propulsion generator that was generating propulsion either by steam or coal or whatever have you, steam coming from nuclear plant, and that's it. And you had an auxiliary system. Now nowadays, because of this energy weapon systems, yeah, that's not efficient. Like there was a bit of transition early on simply because of radars. Radars went from consuming few kilowatts of power to few megawatts of power. Right now there are megawatt class radars installation in sea. So power draw has went up exponentially. So how can you provide that? Auxiliary generator out. We cannot power it auxiliary, like nah. Auxiliary just some emergency systems, like auxiliary will not be able to provide enough power today, let alone tomorrow. It's not happening. So how is Navy and Army solving it? Well, they are jumping into hybrid. Now they are not going to serial hybrid just yet, because be mindful, naval vessels are designed for 50-year lifespan. So in those sort of scenario, if they have already built it, now they are adding it, they can't do serial hybrid properly. So they do the next best thing, that is parallel hybrid. And there are destroyers and cruisers that have that. I have linked the video down below, which already has parallel hybrid. Not amazing, but good enough. Serial hybrid would be the ultimate situation, but it will take time. The new crafts that are being built today, designed today, they will have that. Because the logic is very simple. Power plant, whichever your power plant, be it jet engine, be it internal combustion engine, or be it a nuclear system, that will be powering your generator, and generator will give power to everything else. Because the main generator always has the power. Think in the same way how your car has main motor, like main internal combustion engine, and then have a tiny auxiliary system. Yeah, yield that puppy away, because again, that's tiny. Put a giant generator behind, or a small generator. If you are willing to go with high frequency, you can put a very small generator, get all the energy out. Now you have a power rail that can provide more than enough power. Like I mean, tens to 50s of megawatt power continuously without any hassle. And then you can drive these things. These are some big puppy motors used for naval propulsion, and that puppy is, like, if I'm not mistaken, 30 megawatt. And be mindful, some naval academy, including Rolls-Royce and other companies, they have claimed that they have superconducting, one temperature superconducting motors. Now, what's the benefit of that? Well, efficiency is not the benefit, because this is 98% efficient, and if you go from 98 to 99.5, it's not that big of a deal. However, what is the biggest deal of going to superconductor is that size. So they will go from 300 tons, so to say, to 30 tons. That's like, whoa. That means if, or let's say aircraft carrier, it has 4 motor requirement, they could put 2 superconducting ones and 2 normal ones. So let's say in case of superconductivity failure, they still have propulsion, but if everything is working fine, they're like, hey, we good, we have extra space. So they are all going with that system where you have power plant driving the generator feeding everything. And batteries technology has come a long way. And again, you do not need enough battery to like drive the whole warship. You just need enough to spool up the engine and drive the load at the same time. So that means in kilowatt, you need a very high amount. Kilowatt hour, not that high amount, like a small container ship can do. Container in a ship can do. And Abraham is also getting it. So this puppy that used to consume fuel like there is no tomorrow, utilizing jet engine, that's also getting hybrid system. And heck, this is the latest aircraft carrier, and you can see it has magnetic catapult. That also drains a lot of power. So they have realized very early on, is the latest aircraft carrier that was built after Nimitz class, they overbuilt the power rail very exponentially. Like apparently it's 2x overpowered. Now, like, if radars is not consuming it, this is not consuming it, why they have 2x? They realize they're gonna keep it service for like 50 years. And they know they're gonna add some lasers to it, some Coilgun love to it, some Railgun to it, and who knows, a magical radar to it. So in those sort of scenarios, they're like, yeah, we have learned it the hard way. Thou shall have power rail more than the actual propulsion. So, and this puppy should be able to move at 50 km/h. So it's good enough. And same with Abraham. Again, Abraham will not get a laser that is like, it's spoofing drones, but it can easily have today 1 kWh laser, 1 kilowatt continuous laser, where it can easily blind any drones. So a cheap drone won't get close to it. It's like, hey, where, and that gives the soldier or commander in the vehicle time to just yeet somewhere else. And if drone does not know where you are and you have knocked it out, as in like optically, that's like shut up, take money. Right now it can't be done simply because right now Abrahams have a main engine which is turned off most of the time, and they have an auxiliary generator. Here it's like generator, battery is driving everything, and that allows the hurry up the wait part to be like few hours long. So this is the powertrain. That's how we're gonna have future warfare. So any country that does not have trucks, armored carrying vehicles and tanks and naval ships that does not have serial hybrid, yeah, they're gonna be poofed out of existence very quickly. So this was my presentation on power-based, warfare. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.